Hello everyone, we're going to be going over section 3.3, which is the slope of a line. There are four objectives, the first being to find the slope of a line given 2 points, the second being to find the slope from the equation of a line, the third being use slope to determine whether two lines are parallel, perpendicular, or neither, and 4, solve problems involving average rate of change. So objective 1, we want to find the slope of a line given 2 points. So in our last section, we really focused on graphing lines, and now we want to find the slope of this line. And to find the steepness or slope is referring to the steepness of the line, whether it is very steep, not as steep, anything along those lines. So the slope of the line in the figure below, we begin at point Q and move to point P. So identifying this figure here, we start with point Q, and we're moving to point P. So we're going in this upward direction here. So the vertical change or rise in the change in Y value. So vertical change, this is corresponding to the change in Y values. So we call this the rise. And looking at this picture here, we're saying that the rise is equal to 5. So the rise we have is equal to 5. This is our change in Y, starting from Q up to P there. We're saying that we're rising 5 squares in this case. And our horizontal change, or our run, is the change in our X values. So our run is equal to 3. So our change in our X values there is equal to 3. And we see this difference because our run or horizontal is our change in X. So we see we're going from 2 to 5 in our X values, and our rise or our change in Y values, we are going from 1 to 6. So we're seeing where we have this rise that we have, and then we have this run. And this is just counting those straight line portions of the diagonal that we are connecting with our 2 points. So slope is often known as rise over run. So whatever your rise is, or whatever value you find for your rise, you divide that by the value you found for your run, and that would be your given slope. So in this case, our line had the slope of 5/3. Since we rose 5 and ran 3, we have 5 over 3. The calculation of slope is the ratio of vertical change in Y to the horizontal change in X. The slope of the line in the figure above can also be written as slope is equal to the vertical change in Y, which is the rise, which we said was 5, divided by the horizontal change in X, which we said was the run, to get 5/3. The slope of a line, the slope is a single number that allows us to determine the direction in which a line is slanting from left to right, as well as how much slant there is to the line. So we can generalize to two non-specific points, x sub 1, those are ones, they're not commas or anything, so you have the 1, y1. So we have x1 and y1, and x2 and y2, and find their slope. This notation is called subscript notation, and this is because our x's and y's have subscripts, not to be confused with exponents, which are superscripts or scripts written above our variable or any number in that case. Our subscript has that number written below, and all it's indicating is the distinction of our 2 points. From our figure below, which is this figure here, we see our rise, or our change in Y, is represented as y2 minus y1. And this is going to be represented in units. So y2 minus y1 in units, and our run, or our change in X, is x2 minus x1 units. So we represent them in general with our subscript notation there with our x sub 1 and y sub 1 and x sub 2 and y sub 2. We see our units written are going to be y sub 2 minus y sub 1 and x sub 2 minus x sub 1. So we can generalize a slope formula from this, or using this. So our slope formula, our slope, which is often referred to as M, not S, M. So the slope M of a line passing through the points x sub 1, y sub 1, and x sub 2, y sub 2 is defined as follows. Traditionally, the letter M represents slope. So we say that M is equal to the change in y divided by the change in x, which we now represent that as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, where x sub 1 does not equal x sub 2. If x sub 1 was equal to x sub 2, we would end up with some value divided by 0, which we know would make that undefined. So that would only correspond to a vertical line. So if you don't have a vertical line, x sub 1 does not equal x sub 2. The slope here gives us the change in y for each unit of change in x. So this would be the general formula that we can use for slope if we're just given 2 points and we don't have any graph or any reference to really look at. So subscript notation is used to identify a point. It does not indicate an operation, like we said before. There is a difference between x sub 2 or x squared, which x squared means x times x, but x sub 2 just means second value of x. So let's do our first problem. So we want to find the slope of a line passing through the point -3, 4, and 2, 0. So we do know the definition of slope, and we know how to plot points and draw a line. But let's go ahead and we're just going to do both. We're kind of going to do this little bit of a checking system. So using our slope formula, too close, we can let x sub 1 comma y sub 1 be equal to -3 comma 4, and x sub 2 comma y sub 2 equal to 2 comma 0. So this means that -3 is x sub 1, 4 is x sub y sub 1, 2 is x sub 2, and 0 is y sub 2. So now we can use our equation, which we said was m was equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So in this case, y sub 2 is 0, y sub 1 is 4, x sub 2 is 2, and x sub 1 is 3, -3. So 2 minus -3. 0 minus 4 is going to give us -4. And 2 minus a -3 is like saying 2 plus 3, which is going to give us 5. So in this case, we're saying that our slope is -4 divided by 5. This is what we get from our calculations. But now we just want to check to see if this is correct by plotting our points and graphing the equation. So our points are -3, 4, and 2, 0. So finding -3 first on our graph here, we start at our origin, we track 3 spots to the left here to find 3, and up 4. So we get our point, -3, 4. Then we have 2, 0. So starting at our origin, we can track 2 to the right, and then our y value of 0. So this point is our x-intercept. This is 2, 0. We're going to say graphing the line. Not graphing the equation because we weren't given an equation. And because we weren't given an equation, we can't find another point to check and make sure, but we're going to check and make sure because we already calculated our slope. So now we're going to draw our line. So we draw our straight line here, straight enough, there we go. And now we're going to find our rise over run. So we go from P to Q in this case, which it actually doesn't matter which point you choose, your answer will be the same. So let's just say that this is point P and point Q. So we'll begin at point Q. Momentary lack of judgment. All right, so we pick P and Q here, and we want to find our rise. So we're going to rise to the point of our next point, or the y value of our next point. So we rise to here. And this is our rise. And if we count our rise, we have now gone up 4 positive spaces. So we've gone up 4 positive spaces, and now we're going to do our run. We're going to run now to the left. And by running to the left, we're signifying that we're running in the negative direction. So our run in this case, which is 5 spaces in the negative direction, we get -5. And since our slope is calculated by rise over run, we get 4 over -5, which is -4/5. So our slope is -4/5. We've determined from both graphing these points and plotting these points and graphing our line, and by using our formula for slope. Now, if you wanted to just find the slope of the line passing through these 2 points, you could definitely just choose one of these. You would not have to do both. But that is just to show you both. So from our examples, the one that we just did together, and the images that we saw before, we can assume that a line with a positive slope rises or slants upwards from left to right. So in an image like this, or like this, we see we have a positive slope. We're slanting upwards from left to right. So from left to right, we're going up. But a line with a negative slope is going to fall or slant down from left to right. So in our problem that we just had, we had our graph here, and we know from left to right, we're going downward from left to right. So we can quickly identify whether our graph is either positive or negative by the way that it slants, or we'll know what our graph will look like based on if our slope is negative or positive. We can also make generalizations about vertical and horizontal lines as well. A horizontal line, which has the equation of the form y equals b, so focusing more on our y-intercepts, where b is a constant number, this is going to have a slope of 0. Our flat line has no slope. A vertical line, though, on the other hand, which has an equation of the form x equals a, or this x-intercept, where a is a constant, this is going to have an undefined slope. So this is when our line is just vertical, straight up and down. We can't determine our slope. So our slope has an actual value when it's horizontal, but no actual value when it's vertical. And those are just the key points to really remember. So below we have 4 images that represent the 4 cases of our slopes of lines. So in our first image here, we have a positive slope. We see we are rising from left to right. Our second picture, we have a negative slope. We are falling from left to right, we're slanting down. Our third image has that horizontal line with a slope of 0. And our last image has an undefined slope with that vertical line.